out candy. So I got to pass out. It was cold. Oh my gosh, there was snow coming down. Princesses in coats, down coats. I know it was cold, right, for sure. I all these beautiful costumes covered up by coats. So we had about 12 kids, and they were all my grandchild's friends. So they were coming. It's funny, my grandkid goes with another kid to another subdivision, and then all his friends were going, "Where is Flynn? What the heck?" It's like he's not here. We can try there, Kamaya. I think we're going to try to do that in class for sure. I don't think we have any new people. We had new people today. Thanks for asking, though. I had a lot of new people in other classes. I don't think I have any new people today. So, so what we're going to do, where is it? Okay, here we go. I want to have you guys do this link here. I'm going to share this with you. Um, and copy this. Okay. All right. So this is a word wall that we can do together. Hi, Oz. How are you? This word wall we can do together. If we can do that, I'll show you what it's like. Just a kind of quick review of what the ionic bonding is like. I have a brain freeze there. It's not like I'm even drinking an icy, but it's a brain freeze. Sometimes I get it. Okay. All right, so let me go back and do this. Okay, so this is ionic bond. So help me out with this, ladies and gentlemen. I'm going to turn my camera off so I can see this a little bit bigger. All right, tell me if you're in, okay? Tell me if you're in so that I know that I'm not just talking to myself, because that's what happens a lot of times. I'm talking to myself. That's where I wonder if I'm crazy. Tell me if you're in that assignment. Hey, Rihanna. Hey, Victoria. Anybody in that assignment that I gave you the link for? Oh, there's. Thanks so much. Let's start. All right. Okay. In an ionic bond, atoms are held together by attraction between. What is it? What word am I putting in that? Is it neutral, metal, non-metal transferred ions, or oppositely? Ah, thanks, Jasmine. Oppositely charged ions. Yes, the plus and the minuses. Electrons are blank between atoms. Electrons are blank between atoms. Is it ions, transferred, nonmetal, metal, or neutral? What is that? What word are we going to use in there? What happens when a metal? There you go. Thanks so much, Rihanna. Thanks for that, Jasmine. All right, so they're transferred, right? The metals give an electron to a nonmetal. How atoms gain or lose electrons to form what? What do they form? What do they do? They're plus charged and minus charged. They're electrostatically held together. Anybody got it? What is that? What is it when they have those? All right. Thanks, Jasmine. That is right. That's an ion. Ions are positively charged and negatively charged, and then they're electrostatically bonded together. The ionic bonds is formed between a what cation? What's the cation here? What's that? Oh, you got both of those, Rihanna. Yeah, the metal cation and the non-metal anion, right? The overall charge on those is going to be what? Last one, I can do that myself. Neutral. Let's see if we got a good score on that. All right. How many people got 6 out of 6 on that? 6 out of 6. 6 out of 6. 1 minute 44 seconds. A new world's record. Anybody do it faster than that? No, no, not at all, huh? Okay. All right. Thanks for participating in that, ladies and gentlemen. Okay, so here is the pair deck we're going to be talking about today. 39 seconds, Jasmine, you are so fast. Holy cow, 39 seconds. All right, so here's the pair deck, if you'll get into that. All right, so I'm going to poll you first. Okay, so what would you rather do? What would you rather start a poll here? Okay, would you rather A, Know your death, date of your death. Oh, wait a minute. What am I moving that for? Let me go back here. Know the date of your death. That's A. Control, copy. Let's see that. Control A, V. Let's do V. Or B, know the cause of your death. Now, I would really like to know both, really, because if I've got hit by a car, all right, then I certainly would, if I knew the date, I would not be driving or I wouldn't be walking that day, right? So, and then this is A and B. Okay, start a poll. What do you think? What do you think? A or B? All right. Okay, 50-50 so far. I got two people. Rihanna and Jasmine have both opposed each other. One would like to know the cause of their death. So, maybe they can change their ways. If they had the cause, maybe they would get some help or have it checked out first. A lot of people are saying the date, the date. I've got more people with the date. Oh, now it's even up 50-50. 15 people, 8 out of 14. All right. So come on, Victoria, break the tie. Come on, Tanisha, break the tie. Madison, Kaylee, Joseph, break the tie. It's still the tie, 4-4. Come on, Austin. Where's Aaron? I hadn't seen Aaron in a while. Man, oh man. Well, thank you. Okay, we're breaking the tie. Okay, thank you, Kamaya. You broke the tie. Madison broke the tie. I think Madison broke the tie. Okay, so let's publish the poll. It's 5-4. 5 people over 4 know the date of your death. That was a close one. Okay. Let's start the class. Only 4 people in today. Oh my gosh. So you guys are getting really tired today, I think. You guys are really tired. We're going to try to work on some assignments here at the end of the hours. So let's do that. All right, so a reminder of ionic bonding. They form between a metal and a nonmetal. They bond together, fill their octet in a valence shell for both atoms to become stable. Stability occurs when atoms lose or gain an electron, where both atoms become an ion and cause that attractant, the electrostatic attraction, right? All right, so we talked yesterday about these things, okay? Those are the valence electrons that group 1 wants to give 1 electron away, because remember, metals want to give away and nonmetals want to take. All right, so we will talk about that. So today, I can review ionic bonding theory. All right, so to understand this, you can see the electron is being transferred, right? And if I look at this, this is a positively charged ion. This is a negatively charged ion. They're held together by the charges, right? So they're very stable. Okay, cations are the first. So when we're naming, so we're doing naming today. Cation is first when you're naming, always the metal. The anion second, and we use an ending, we change the ending to "ide." So if it's bromine, because bromine is a non-metal, so when we get to the I, we just put De, bromide. So fluorine, Flour, I makes, then right after the I, we put De, fluoride. So something that goes in your toothpaste, fluoride. So potassium fluoride. So we don't change this word, but we change the "ide" on the end. And that's how we know. And somebody made this up. Not sure why. Somebody made it up, right? Somebody made it up. And that's what we got. Okay. So, and there we have covalent bonding has a different set of rules. All right, so let's first talk about this. I've got, so I'm going to work with this. So let's take a look at counting atoms. This is our first chance at counting atoms. It comes in handy when we have to account for things, what we call imbalancing equations, which we'll get to. That is probably the what you call the high point of chemistry, trying to balance equations. All right, so here we go. So if we're balancing these equations, or we have to count atoms, okay? So we do that. So if I put a subscript, so if I do a subscript here for sodium, chlorine, now remember a subscript, so remember there is 2 to the third power. That's a superscript. But now what we're doing is we're moving it down here, and now it's called sub or below script. Script means right, right below, right below. So what this means is it tells me this is a molecule, okay? And this molecule has one sodium atom in it, two carbon atoms, three hydrogen atoms, and two oxygen atoms, right? We don't have to write the one, okay? Now, do you remember from math, if I do this in the brackets, we do the distributive law, we go 2x plus 10. If you guys remember in algebra how that works. Well, think of this as a bracket right here, and then put a 2 there. So this multiplies, this says I have 2 of those. So that means if I count up all the atoms there, I'll have 2 sodiums, I'll have 4 carbon, I'll have 6 hydrogen, and 4 oxygen. So that kind of multiplies everything. Got to remember this is a 1 there, right? And think about that. So the chemical formula is the chemical composition of the matter being discussed, each used to count atoms for each element. All right. So those subscripts tell us about that. So what I'm going to do is I'm going to take a look. I'm going to take a picture of this because we're going to, I'm going to have to shut off my pen, and then it always reduces it. So let's see who is in here working today. All you guys, Mr. Gale's a slave driver for sure, for sure. He wants to know how you guys are doing. And I have had people working for me every day this week, and I really appreciate it. Let's see who's working for me today. And I thank you for that with your bonus points I add on. All right, Jasmine's there. I think, Jasmine, you've been doing this every day this week. Yes, every day this week. Okay, Jasmine and Kamaya. Yep, every day this week, all 3 days. Thanks, Kamaya and Rihanna. So we only have 2 people today of our 17. Oh my gosh. Hi, Phoebe. I didn't see you come in earlier. And who else didn't I see come in? Mariana, I didn't see you. Good to see you. And yeah, I saw Oz. Oz said hello this afternoon. So Rihanna, okay. Anybody else want to get in there? Not hard work, it's just practice. Keeps you from falling asleep, right, Oz? Keep you from falling asleep. I got another person. Thanks, Bradley. Anybody else want to get in there while I'm counting the people up? Thanks, Bradley. Bradley's worked today and yesterday. Thanks. What? Oz, I've said something to you, right? Okay, let me get that. There's what you need to write down. Are you going to get in there, Oz? You know you're going to fall asleep if you don't, you know? All right, no link. Okay, let me get that link to you again. All right, here we go. Paste. Here we go. Thanks for asking. Say, Mr. Gale, where's that link? All right, close that. Put that back up. 1, 2, 3, 3. 1, 2, 3, 2. Okay. There we go. Okay, so let's move on to the next one, and hopefully we'll pick up some stragglers. And it's my fault I didn't have the pair deck listed up there. I don't know why. Okay. So let's start working on this. Okay, so what you're going to need is your P table, and I'll give you this link right there, right? The link to the periodic table. All right. Here's the link for the periodic table. If you have two screens, it's really nice to have one screen showing it and then the other screen doing that. If you don't have two screens, that's something I would ask for Christmas. All right, so we're going to take a look at the presentation here. So we have CAS. Okay, so let's kind of review this. To name an ionic compound, write the name of the metal, the cation, followed by the name of the nonmetal, anion, with an IDE ending. So instead of calling it sodium chlorine, we call it sodium chloride. Okay, so we're going to talk about CAS. So I have to use my periodic table and look up Ca. Now, where would Ca be? On the right side or left side? Anybody want to tell me in the chat here? Would Ca be on the right or left side? The reason I'm asking is because if you know what Ca is it a metal or nonmetal? Metals are on the left side and nonmetals on the right. Anybody know what we're talking about? Ca, a metal or nonmetal? Metal or nonmetal? Thanks. Yeah, so Ca will be on the left-hand side. Here it is. Ca right there. So we're going to write calcium. And S, where would S be? Would it be in the metals or nonmetals? Where would S be? The metals or the nonmetals? Metals or nonmetals? Because remember, we're making ionic compound. Thanks, Rihanna. So yeah, so S is over here. That's sulfur. So we're going to take the SUL F and put an IDE on there, sulfide. So we're going to call this calcium sulfide. So you got to know where it is on the periodic table. So let's do that. Let's put it on the periodic table. I'm going to try to write this out. Okay, so this, let me change this to blue maybe. Yeah, there we go. Okay, blue. So this is going to be calcium. I substituted in a first grade class, and they told me I had the worst handwriting. That was the students telling me that. Calcium. And remember, we're going to say sulfide. SULFIDE. Calcium sulfide. Yep, I still have terrible penmanship. Calcium sulfide. All right, calcium sulfide. So looking at my periodic table, so where is Ba going to be, on the right or left? Anybody know where Ba is going to be, right or left? Metal or non-metal? Anybody know? Already, Ariana knows. Okay. Ba is going to be on the right. So that means it's a non-metal, right? Okay. Non-metals are on the right. Metals are on the left. Okay. So Ba is right here in column group 2, Ba for barium. And the other one, what was the other one? I forgot. Br. So where's the Br going to be? Metal or non-metal? Oz, I'll let you fix this one. Is it going to be a metal or non-metal? Br. What do you think? Metal or non-metal? Put you on the spot, Oz. So we have a metal and a non-metal. We already found the metal. We already found the metal. So Br is going to be the nonmetal. So if we go to the right for the nonmetal, that's the second one. Ba is going to be the first one, and Br is going to be the second one. Now this is kind of cool. All we have to do is put a De for bromine, put a De, and we've got it. So it's going to barium bromide. So barium bromide. Barium and bromine. So it's bromine. IDE, bromide. Okay. Barium bromide. Okay, we got 5 out of 7 people. I think we got, did we pick up somebody else? Barium bromide. Let me take a picture of this. And I'll take a look and see if I got a new person or not. All right, so here is the chart there. And who do I got? Who do I have? I have Jasmine. Oh, good job, Surya. Thank you for getting in there. I thought you, and again, it was my fault. You didn't have that. This is great. 3, good job. So got one more person. Shona is in there as well. Thanks so much. And we've got Rihanna and Kamaya. Who did I lose? Did I lose somebody? Oh, maybe I lost. I got everybody. Oz is still waiting there, and Bradley's still waiting there. Come on, guys. Let's get in there. Okay. Got everybody? Nope. Okay, so we are moving on. They probably have a laggy computer at last, or they walked away. I've had people walk away. I'm asleep. You're always asleep today, Oz. Okay, get up and do some jumping jacks for me. Then wake yourself up. All right, so calcium sulfide, barium bromide. All right, so let's try again. Let's practice this. Do some jumping jacks. How about 10 push-ups, Oz? Can you do 10 push-ups? Can you do 10 push-ups? What's what's a push-up? All right, good question. All right, so BAO. Okay, Oz, what is O? Is that a non-metal or a metal, Oz? Okay, metal or non-metal? What's the O? Yeah, O for oxygen. Is it metal or non-metal? You got it. Is it on the right side or on the left side? Okay, nope. Left side is the metals. Oxygen's on the right. Okay. All right, so Ba, so barium. Now here's a little crazy part about this oxygen. It's not barium oxygen, so we go just the OX and then IDE. We get rid of that YGEN and put IDE there. Okay, so this is going to be barium because we write the whole name and then OX IDE. All right, barium oxide. All right, so let me see if I can get Kamaya. What's Li? Is that a metal or non-metal? Can you tell me, uh, Kamaya, what is Li? A metal or non-metal? Khalees, how about you? Can you tell me if Li is a metal or non-metal? Oh, there's Kamaya. Thanks, Kamaya. Yeah, this is a metal. So, Khalees, where would the metal be found in the periodic table? Right or left side? Right or left side? Oh, you got it, Oz. Lithium. Li. Khalees, are you there? Nope. How about you, Joseph? Is metals on the right side or the left side? Here's the metals. Here's the non-metals. What do you think, Joseph? Metals, non-metals, right or left side? I'm not really good with right or left. I get it backwards a lot of times. No, Joseph. All right. Phoebe, right or left side for metals when you're looking at the periodic table? Quiet. My gosh, I hear crickets. Crickets today. Okay, lithium is on the left side. When I hear crickets, that means people. Thanks, Oz. If I hear crickets, that means nobody's listening. Nobody's listening. All right, so it's lithium, and we already did oxygen. So this is going to be lithium. Notice that because even though it's the 2 is on there, we don't change the name. Lithium oxide. Even though it has a 2. Well, unfortunately, that's going to happen. It's going to change the name for covalent bonded materials next week, but we don't have to worry about it now. All right. So remember, this is the metal, left side, left side. And this is the non-metal. You're going, Mr. Gale, really? Why are we learning this stuff? Because I need some of you guys to be chemists someday. Metal, left side, non-metal, right side. Okay, so magnesium and what's the F? Fluorine, right? Fluorine. And that's nice because all we have to put is an IDE at the end. All right. So magnesium. Fluoride, Fluoride. And this one is sodium. And this is kind of strange. Nitride, Nitride. Okay. All right. Did I get any new ones? Jasmine's there. Kamaya, Renaya, Bradley. Thanks, Bradley, for getting in there. Got lost a few people. All right. Too much work for you guys, I'm afraid. So, okay. So barium oxide. So pretty straightforward, right? Okay. So this is the last thing we're going to do. When you have the valence electrons up here, okay, right? So this is calcium. It's in group 2. It's 2 positive because it loses 2 electrons. That's why it makes it positive. Here, this one gains 1 electron, gains 1, because remember, metals lose, non-metals gain. This gains 1. So what we do is we use those subscripts, get rid of that, and that becomes, I'm sorry, the valence electron, and put it as a subscript. And then remember, we don't use the 1, so it becomes calcium fluoride. So what that means is, so if I were to draw a picture of this, every calcium would have 2 fluorines attached to it. Okay. The reason being, because fluorine only wants 1 electron, calcium wants to give up 2, so it can give up 2 to the 2 fluorines. That's what this looks like. And as far as the model, it looks like if it came in a model, it'd have 1 red and 2 blues. Right? So in this particular case, these are both 1s. So all we have to do is put NaCl. NaCl. And that's how we write the formula by using the ionic compounds crisscross method to find the coefficients. Okay. All right. That is it for today as far as that. Now, what I want to say is, okay, and I'm going to, let's see if we can work on this together. All right. Where are you, my group members? Okay. Let me go here. Okay, so what we're going to do is we're going to do a breakout room. And the breakout room, I'm going to go over an assignment with you guys. So I'm going to